On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at several examples of what's called one-sided limits. We got two different graphs to look at. We have a f of x graph and a g of x graph. These first 5 questions deal with the f of x graph, as you can see here. We have some new notations here. This minus right here. The way we read this is the limit of f of x as x approaches 2 from the left. That is not a negative 2. If it was a negative 2, we would be putting that negative on the left-hand side here, just like you write all negative numbers. So this means we are approaching 2 from the left. We're trying to approach this x value of 2 on our f of x curve, and we want to come from the left-hand side. So that means we're coming from this way, and we're approaching 2 from the left. So let's go on our curve, and we're on our green curve, and we are approaching this value of 2 from the left. Well, what y value are we getting close to? It looks like we're getting close to a y value of 3, even though the function's not defined there. So this is equal to 3. Look at question B. The limit of f of x as x approaches 2 from the right. Now we're still trying to approach this same value of 2, but we're coming from the right. So we're on this part of our curve. And what y value are we getting close to now? That y value is a 1. So that will be our right-handed limit. Now, something important to note here. If the left-handed limit and the right-handed limit are not the same, in this case they are different, therefore this question here would be this limit does not exist. Now let me explain that again though. Because this question in C says the limit of f of x as x approaches 2. Well, if we approach 2 from the left, we go to 3. If we approach 2 from the right, our y value goes to 1. We are approaching 2 different y values. Therefore, one of the conditions for a limit to not exist is when you approach 2 different y values. Question D, f of 2. This is not a limit. This is just asking you to find what's the value of f when x is 2. That's what this closed dot means right here. So f of 2 is equal to 1. These concepts are going to be important for determining limits, and later on when we talk about continuity, these ideas of left-handed limits, right-handed limits, and the actual value of a function, all of those are going to be important in future tutorials. Now, for this last one here, the limit of f of x as x approaches 4. So we're trying to approach this x value of 4 right here. Well, regardless if we come from the left or from the right, we are approaching a y value of 0. The y value there is 0. So this limit does exist, and that limit is going to be 0. Regardless of the left-hand side or the right-hand side, we are approaching the same y value. Let's look at these next 5 examples. This function, g of x, looks similar, except now we don't have this jump right here in this particular problem. So now, using our new notation, the limit of g of x as x approaches 2 from the left, well, this is that same curve really that we had over here. If you notice, it's zoomed a little bit different, but as we approach this x value of 2 from the left, we are on this part of our curve, and as we approach 2 from the left, we are getting close to a y value of 3. Even though the function's not defined there, that left-handed limit is going to be 3. Question G, the limit of g of x as x approaches 2 from the right, so we're coming in from this side. Well, notice this is also getting close to a y value of 3. Therefore, since the left-handed limit is equal to the right-handed limit, then we can say the limit of g of x as x approaches 2, it does exist, and it's going to be equal to 3. However, question I, g of 2. We do not have a value defined anywhere when x is 2. That's an open circle. The function is undefined there. We have a hole in our graph. So g of 2, I don't see a dot or anything. Therefore, we say this is undefined. Now I'm just going to write UND to save a little bit of space. Last but not least, the limit of g of x as x approaches 4. So now we're approaching this x value of 4. Well, it looks like right there, that's going to be our limit, because here the left-handed limit and the right-handed limit, they're both approaching the same y value, which is 2. So that is going to be our limit of g of x as x approaches 4. And there you have it, 2 examples, new concepts here, left-handed limits, right-handed limits, talking about when a limit does not exist. Recapping from a previous tutorial, we did mention there where if we approach 2 different y values on the left-hand side and the right-hand side, if those 2 values are not the same, the limit does not exist. Whereas over here, we did get the same limit both on the left-hand side and the right-hand side, hence that limit did exist. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.